Good morning, I'm Santosh, Assistant Professor. So today we're going to discuss about the topic called digital phase meter. So let's see what is digital phase meter. So before that I just give a construction how it is, what are the parts are there. So actually here we have preamplifier, attenuator, zero crossing detector, and we are using two flip-flop, and we have ungate and mounter. So what is the purpose of digital phase meter? So actually here this meter is used to find the phase difference between among the different waveforms or signals. So in this case we have going to compare the two signals. So one is first signal, another is the second signal. Both are sine wave, but this is going to be changed to a perfect square wave, and also we are going to find the phase sequence, the difference between the two signal one and signal 2. So let's see the first case, how it is work. So actually here we are going to give the two phase two waveform with the same frequency, but there may be a difference in phases. The first waveform phases is phi naught, the second waveform phases is phi x. So first waveform is given. Here we have the preamplifier and attenuator, which is act as a filter and removing unwanted signals such as harmonics, everything, and we are providing the pure signal to the next case. So here we are going to check when it is crossing the zero. So whenever it is crossing the zero, and it is given to the flip-flop. So here you can see. So this is the first signal. The signal starts from 0. So now it is crossing the first 0. So that is taken as 5. Okay. So here, so once it detects the 0, then this will be triggered clock 1 and the output will be high. The Q generate the high. So because of this, the AND gate is provided high output, the AND gate is enabled. Now the counter counts 0, 0, 0, 0, 1. So it's a first count. And come to the second waveform, the same thing or doing the same for the second waveform signal. So here we have the preamplifier attenuator, same thing, removing the unwanted harmonic signals waveform. After the zero crossing detector, it's going to find when it crosses the 0. So definitely this signal will not be the same time it won't cross the 0. There will be some lagging in crossing 0. So that second signal crossing 0 at this point, for the first signal crossing 0 at this point. So this will be the actual phase difference between the first signal and second signal. So now when it crossing 0, now the second flip-flop is